So, why did the early astronomers look to the skies? Careful, long term observations of the sky by early sky watchers led to the first calendars. The days are organized into a schedule of larger units of time, such as weeks, months, seasons, or years. Celestial priests and priestesses studied celestial objects, such as the sun, other stars, the moon, and the planets. Today, our year is determined by the number of days required for the sun to return exactly to the same place in the sky with respect to the background stars. Our year is determined by the time it takes for the Earth to make one revolution. A revolution is the time it takes for an object to orbit another object. The Earth's revolution around the sun is 365.24 days, which is why we have a leap year every 4 years. The early clocks they looked at the sun to determine the time of day. So 1 day is the average time it takes for the Earth to make one complete rotation on its axis with respect to the sun from noon until noon. So the rotation is the turning of an object around an imaginary axis running through it. Next, we will look at the constellations. Constellations are patterns in the sky. They are a group of stars that seem to form a distinctive pattern in the sky. So, for example, Ursa Major is an example of a constellation, within which is what's called the Big Dipper. So, the Big Dipper is something highly recognizable, but it is what's called an asterism. An asterism is a pattern of recognizable stars that may be part of one or more constellations, but not officially recognized by the IAU. And a light year is the distance that light travels in 1 year, which is about 9.5 times 10 to the 12 kilometers at a speed of 300,000 kilometers per second. So we multiply that by seconds that are in a year to get the distance that light travels in 1 year. Apparent magnitude is the brightness of a star seen from Earth, and it depends on the size and color of a star.